Which one of these options is better to protect your software from reverse engineering? To hide the password in front of a hacker? Well, they are all terrible. Let me walk you through them, show you why, but show you how to do it properly as well. As always, the tool doesn't matter that much, as you should understand the principles in the first place. For that reason, today I'm not going to use IDA as usual, but Binary Ninja. Just download it and it's immediately ready to be used. No registration required. Level 1. Let's keep the password in a plain text. Nothing fancy. It's just right there. When I distribute the binaries and someone runs the program, of course they have no idea what the password is, right? So can I implement protection this way? No. Let me look inside. I can see a graph of what's happening. Choose the main function and view the pseudo C code. That will do its best to present the instructions in a more human-readable form. Can you see it? It's just there. If you are going to hide password in your software like this, it takes just a few seconds to overcome, not even that. I don't even need to patch it. I can run the program and just use secret 123. Level 2. What about something more sophisticated? What if I compare the user's input with the correct password character by character? You might think that this will change something, as the program doesn't directly access the string as a full string. Well, and really, if I check it out in pseudo-C, it's not as obvious. However, I can open the string list to see all the strings which my app uses. Here it is. In a real-life scenario, it might be a little messy and there are numerous strings. So what I can do is to switch to high-level intermediate language. If an attacker uses modern tools, it takes them again just a few seconds. This is slightly better than the previous case, but still bad. By the way, even in pseudo-C, I can see the password. When I just hover the mouse above, I can immediately see the correct memory segment and read code break. Level 3. What if I don't use a string, but arrays and character by character instead? Sounds good, but it doesn't work. Let me show you this. I create a string, like a string, and the same one as I just showed you. In a memory, from the computer's perspective, they look the same. Question is it going to be the same from a hacker perspective as well? To spice things up, I added debug detection, which immediately stops the program if someone tries to debug it. The good thing is that there is no ninja string. The bad thing is that it doesn't matter, because Binary Ninja has no problem understanding what is happening. For good measure, let me run it. I step through the code, enter a password, and as you can see, I get hit by the anti-debug protection. This part works, and you could see it in action in my previous video with a CrackMe challenge. I leave a link in the description. Level 4. Alright, let's stop messing around and get real. How can we actually hide a password? Ideally, the password wouldn't be there at all, but that's kind of problematic because we need something to compare the user input against. The next best thing is to encrypt it. A super efficient method is using the almighty XOR. In C++, I have an encrypted array of characters and the key, which is 42 in hexadecimal. Whatever the user input gets XORed with 42 and compared with my password. This way, the string is hidden, at least a little bit. Unfortunately, in Binary Ninja, you still see these nice little arrays of 4 bytes and a loop that does input XOR 42 and compares it. If attacker knows what they are looking at, it's clear that the program takes the user input, XORs it with the key 42, and compares it to these arrays. It's slightly better than before. The password isn't in plain text, and the attacker needs to understand this operation. You can imagine a follow-up. You would make life way harder for a hacker if you could hide the key as well. Think about variations on that and let me know in the comments. By the way, if an attacker knows the encrypted password and the key, they can easily write a simple Python script to reveal the true password. The paid version of Binary Ninja includes a Python console, but I'm using the free version, so I must run Python script aside. Don't hesitate to combine tools. That's why I insist you shouldn't get too attached to one piece of software. You should always understand the principles first. Over time, you'll definitely find your favorites, but at the beginning, focus on understanding the steps, not just thinking, I should click here and magic will happen. Level 5. We are on a good track with hiding the password from plain sight, but let's do something even funkier. What if I don't use a simple XOR? where you only need to guess one number in our case, but instead a special algorithm. Let's say our password is Ninja again. I can use this hash function to turn it into gibberish. It's a custom one, resembling XXH32. A hashing function is a special beast that turns any input into seemingly random pile of characters. The thing is, the same string is always converted into the same pile. And at the same time, even the slightest change in the input causes a massive change in the output. So attacker has no clue whether they are getting any closer to cracking your password, even if they've guessed the algorithm. When it comes to password protection, this is already pretty good. It would take a huge amount of work on the hacker's side to figure out what's going on, especially if you are using a non-standard hashing function. So someone would have to really want to know your secret. However, realistically, this only makes sense if the password is generated on the fly and the attacker is trying to write a keygen. In a normal scenario, where they just want to get in, they'd simply write a patch to bypass the password check entirely. Protecting your software is a pretty interesting topic, and you can learn a lot by experimenting and trying to figure out how to overcome your own protections within legal boundaries. It's fun to write a simple CrackMe challenge. Maybe write just a small program that asks for a password and share it with your friends. Can they break your protection? You can watch more videos about reverse engineering and CrackMe challenges. I've left the playlist in the description. For now, that's all from me. Thanks for watching, and if you want to see more in the future, hit the subscribe button. See you next time.